What's the idea of Quicksort? The basic idea is pre-sorting. And in my personal life, I sometimes use pre-sorting. The situation is I have a heap of, let's say, 60 exams, and then I have to order them in the alphabetical order. And it's not so easy ordering 60 exams. It takes a lot of time. Ordering alphabetical on top to the task of ordering, the task of deciding which one is the smaller and which one is the larger element is not so easy. Is O before R or is R before O? To decide that it takes more time than to decide is 18 more than 11 or it's the other way around. Okay, but when I have to order the heap of 60 exams, sometimes I use the concept of pre-sorting. I take the 60 exams and then I say, let's take the exams in the first half of the alphabetic to the left-hand side, and let's take the exams in the second half of the alphabet to the right side. And after doing so, I have two heaps which are half the size, approximately half the size, and then I have to order 2 times 30 exams, and that takes less time, and that is the idea of pre-sorting. Let's illustrate the idea with this deck of cards. First, we have to find the middle, and it's not so easy to find the middle if you don't know the range of the numbers. So an easy idea is let's take the first element, let's take the last element, let's take the mean value of these two. In this case, this is 13.5. And then let's decide to the left-hand side everything what is less than 13.5, and to the right everything what is more than 13.5. And we can do that in a very easy way. Here, being a human, it's a task we can do very fast with 9 cards. But what is the concept? We will do that. And this concept is very effective in terms of the number of swaps in the memory. So let's illustrate the idea of Quicksort, and let's do it in detail. Our pivot element is 13.5. Let's check, is the first card on the left-hand side or on the right-hand side. 11 is less than 13.5, so it's on the correct side of the deck, so we don't have to do anything. Let's step 1 position to the right. Now we have 18. 18 is more than 13.5. It's on the left-hand side of the deck, so this card is not in the correct position. Let's remember that. And we remember that because we stopped the process of going to the right. Here we said it's okay, let's go to the right. Not okay, so let's stop here. Now let's check 16. 16 is more than 13.5, so 16 is on the correct side. 17 also, 10 not. 10 is less than 13.5, and on the right hand side we want the elements more than 13.5. So now we have found 2 elements in incorrect position, so let's swap and let's step 1 position. Now this is incorrect side, 13.5 and 14 is more. This is incorrect side, 13.5 and 13 is less. So we found another 2 elements on the wrong side. So let's swap these 2 elements. Let's step 1 position. And now let's begin here. Correct side, correct side, correct side. Now these 2 are in the position, the red piece or the orange piece is right to the blue position, and so this is the splitting point. We did not know in advance what is the splitting point. That is why it's very, very clever to use that concept. But now we know here is the split. Here to the left are all the elements less than 13.5, and here are all the elements more than 13.5. Now we have to order these 5 cards. Which concept will we use? We will use once more Quicksort. It's also a recursive algorithm. Recursion is very powerful. It's a little confusing being a human. If you never heard about recursion, in the first moment it's confusing, but it's a very clever concept, very powerful, and in truth it's an easy concept. Now let's order this deck. Let's choose the pivot 11 and 7. The mean value in this case is 9. So all cards less than 9 to the left, all cards more than 9 to the right. What is if there was a 9? We have to decide, okay, let's say less than 9 to the left, more or equal than 9 to the right. So let's start here. 11 is more than 9, so incorrect position. Let's stop here. 7 is less than 9, so incorrect position. So let's swap these two. Let's step 1 position. Let's check for the red piece. Is it less than 9? No, it's not, so incorrect position. Here check more or equal to 9. No, so incorrect position. So let's swap. Let's step 1 position. The red piece, is this less than 9? No, it's not, so incorrect position. Let's take the blue piece. Is it more than 9? Yes, it is. Step 1 position, and now these two change the side. Normally the red piece is always left to the blue piece, but now that changed. Now the red piece is right to the blue piece. And in this moment we know, okay, now we can split. This is the splitting position. Here are all elements less than 9. Here are all elements more or equal to 9. So now we have 3 parts here, these 3. And recursively, let's order this. Now let's order this deck. The pivot is 6. 7 is more than 6, so incorrect position. 5 is less than 6, so incorrect position. Let's swap. Let's step. Now they crossed. So this is the position we split the deck. Now on the left we have only 1 card. 1 card is always sorted. On the right hand side we have also only 1 card, so this is sorted. And now we know these 2 cards are in correct position. Now let's order these. Pivot is 12, incorrect position, incorrect position. So let's swap, let's step, correct position. Okay, now they crossed. Let's split. To the right hand side we have only 1 card, so this is ordered. We have to order that deck. The pivot is 10.5, incorrect, incorrect. So let's swap, step 1 position, and now let's split. 1 card is ordered, 1 card is ordered. So ordered, ordered, ordered. And now we can come to that part. Let's order these 4 cards. The pivot is 15, correct position, incorrect position, correct position, correct position, correct position. They crossed, so let's split. To the left only 1 card, so nothing to do, it's ordered. And to the right 3 cards, so we have to do something. Pivot is 17, and incorrect position, let's swap, let's step. 17 is not less than 17, so incorrect position. This one tells us yes, correct position. Let's step. Now they crossed, so let's split. Only 1 card. Okay, so let's order these 2. Pivot is 17.5 and let's step. They crossed. So let's split. One card ordered, and now we are done. Now we completed the job, and so the field, the array is ordered. This is the principle of Quicksort. This is how it works. It seems to be a little bit awkward. I think that's true, because being a human, if you have to order 3 cards, there is no algorithm you need. You see in one moment, okay, this is the correct ordering. And being a human, you don't want to use a logic. It's obvious what is the correct ordering. But the principle of an algorithm is telling a computer, and for a computer, nothing is natural. So you have to use some algorithm to bring 3 cards into the correct order, and why not using Quicksort? Okay, let's have a look into the code. Okay, this is the code of Quicksort. First, what is the number of elements? If this number is 1, then the field is ordered and nothing is to do, so we can return the original field. Then let's find the pivot. The pivot is the first element and the last element and the mean of these two. So this is the pivot. And I1 is the red piece. It will run from the left to the right. And I2 is the blue piece running from the right to the left. As long as the red piece is left to the blue piece, or maybe it can also be on the same position, we will step. So if the red piece is somewhere where we are less than the pivot, we will step. But only as long the field, we are not at the end of the field, and only as long as the red piece is not right to the blue piece. As long as this is true, we will step the position of the red piece. Then we will come to the blue piece. As long as the blue piece is on a position where AI2 is more or equal to the pivot, let's step, but only if we are not at the beginning of the field, and only as long as the blue and the red piece did not cross. And as long as that is true, we will decrease the I2 counter the position of the blue piece. So if we found 2 elements on the wrong side of the field, then we will swap these 2 elements, these 2 cards, and we will step the 2 counters. The red piece 1 position to the right, and the blue piece 1 position to the left. If that is not true, then we had a crossing without the need of a swap, and so we have nothing to do. But we will stop this loop, and now we can split. A lot of lines of the code here, these 2 are special cases. They can only happen if the card on the first position and the card of the last position are of the same value, and then the pivot is this element, and by coincidence these 2 elements were the smallest ones or the largest ones, and in this case something special can happen. It's not really helpful to care too much about these specialities, so it's a lot helpful only to focus on that. And if you understood in detail the concept of Quicksort, then you can think about these special situations, and I don't want to spend too much time on that here. Now we will sort the left part of the deck and the right part of the deck independently, and then we can combine these 2, and in comparison to merge sort, there's nothing to do because of the pre-sorting, and so we can stick these 2 parts together. Okay, that was Quicksort.